Let us see some peripheral smear slide pictures. Here WBC count appears to be significantly increased. So there is leukocytosis. And in this picture, the WBC shows shift left. What is shift left? Shift left is the immature myeloid precursor appearing in the peripheral blood. Normally they are not seen in the peripheral blood. So immature myeloid precursors or neutrophil precursors are seen in the peripheral blood. Here we can appreciate a myelocyte with its oval-shaped nucleus and the cytoplasm containing primary eosinophilic granules and lilac-colored secondary granules. And here we can appreciate a neutrophils with 3 to 4 lobes connected by delicate strands of chromatin and condensed nucleus. So this here is a mature neutrophil. So there is shift left or immature myeloid precursor in the peripheral blood. Here again shift left. Here is a myelocyte with oval-shaped nucleus and cytoplasm containing primary eosinophilic granules and lilac-colored secondary granules. Here is the metamyelocytes with the kidney-shaped nucleus or indentation less than 50%, 50%, and the cytoplasm will again contain primary eosinophilic granules and lilac-colored secondary granules. And here is a band form with the band-shaped nucleus or indentation more than 50%, 50%, and the cytoplasm again will contain the primary eosinophilic granule and lilac-colored secondary granule. So there is shift left or immature neutrophil precursor such as myelocyte, metamyelocyte, and band form. And here is a blast. This blast has got an enlarged nucleus or high nucleus cytoplasmic ratio. And we can also appreciate these whitish opacities which are prominent nucleoli. These blasts are active cells. So they have got a dispersed chromatin, unlike the condensed chromatin in the mature lymphocytes. So because of this dispersed chromatin, we can see prominent nucleoli. So there is shift left and there is leukocytosis, and also we can see these cells, arrowed cells. These are basophils. So they have got these prominent violet-colored granules which are obscuring the nucleus. These granules obscuring the nucleus. These prominent granules. These are basophils. More than 2% basophils. That is called basophilia. So there is leukocytosis, shift left with the myelocyte, metamyelocytes, band form, etc. And there is 1 to 2% blast. With this, the diagnosis is chronic phase of chronic myeloid leukemia. CML usually presents in elderly individuals more than 50 years of age, and they usually present with the dragging sensation in the abdomen, and there is marked splenomegaly. So marked splenomegaly and dragging sensation in the abdomen, elderly age, and peripheral smear shows this picture. Marked leukocytosis and WBC count is significantly increased leukocytosis with the shift left myelocyte, metamyelocyte, band, etc. in the peripheral blood, and 1 to 2% blast. And there is basophilia, more than 2% basophils. So these are the peripheral smear finding in a chronic phase of CML. If you look at a marrow, there is increased cellularity, hypercellular marrow, because CML is a myeloproliferative neoplasm. Increased paratrabecular cup of immature granulocytes, such as myelocytes, metamyelocytes, etc. Normally, it is only 2 to 3 cell layers thick, this paratrabecular cup of immature granulocytes, but in CML it becomes 5 to 6 layers thick. And also there is hypolobated megakaryocytes or dark megakaryocytes. What are these dark megakaryocytes? Normally megakaryocytes has lobated nucleus and abundant cytoplasm, abundant granular cytoplasm. Only the ploidy increases 4N, 6N, 8N, 16N, but the cell doesn't divide. So there is increased lobation of the nucleus as well as granular cytoplasm, granular cytoplasm. In hypolobated dwarf megakaryocytes, there will be less lobation and cytoplasm is less compared to normal mature megakaryocytes. So hypolobated dwarf megakaryocytes, hypercellular marrow with the increased paratrabecular cuff of immature granulocyte. These will be the bone marrow finding. Then what is the genetic abnormality seen in CML? The genetic abnormality seen in CML is translocation 922. In 22 there is BCR with the serine threonine kinase activity, and in chromosome 9 there is ABLG. This ABL has got tyrosine kinase activity. When translocation 922 occurs, this BCR ABL fusion occurs. So this BCR with this serine threonine kinase activity augments the tyrosine kinase activity of ABL. So there is translocation 922 and there is a protein called P210 with the increased tyrosine kinase activity. How can we demonstrate this translocation 922? We can demonstrate them with the RT-PCR, karyotyping and FISH. One problem with the karyotyping is that it analyzes all the metaphase chromosomes. But the problem with this is that it can miss cryptic translocation. Cryptic translocation can be missed in the karyotyping, which analyzes the metaphase chromosome. And there is RT-PCR and FISH. In FISH, we can label, fluorescent labeling can be given. Suppose we give BCR on chromosome 22 for red. ABL, we give the green color, PCR red labeled, ABL and green labeled. If there is fusion occur between this translocation chromosome 9 and 22, BCR ABL fusion and P210 protein, increased tyrosine kinase activity. If such process occurs, there we can appreciate two yellow signals. So there is, if two yellow signals are there, there is fusion between this chromosome 9 and 22. That is fluorescent in situ hybridization. Suppose in addition to these two yellow signals, there is one more yellow signal. So there is additional Philadelphia chromosome. This BCR-ABL fusion protein or BCR-ABL translocation 922 also called Philadelphia chromosome because the discovery goes back to Philadelphia, a place in the US. If there is additional Philadelphia chromosome, additional yellow signals, there is transition to the accelerated phase. So other phases are accelerated phase and blast phase. C is the chronic phase, A is the accelerated phase, and B is the blast phase. In accelerated phase, WBC count further increases, or platelet count further decreases or increases, increasing thrombocytopenia or thrombocytosis, increasing leukocytosis, and the splenomegaly, which is a clinical feature of this, can further increase. So increasing splenomegaly, increasing leukocytosis, increasing thrombocytosis or thrombocytopenia, all these are features of accelerated phase. Also, there can be additional Philadelphia chromosome. There is 3 yellow signals. And also one other feature is increased basophils. Basophils more than 20%. Increased basophil more than 20%. Blast 10 to 90%, 19%. So 10 to 90%, 10 to 19% blast. Basophil more than 20%, increasing leukocytosis, increasing splenomegaly, increasing thrombocytosis or thrombocytopenia. All these are features of accelerated phase. Then there is blast phase. Blast phase, there is 20% blast. This 20% blast can be myeloid or lymphoid. Majority case it is myeloid, but can be lymphoid also. So blast crisis means 20% blast and acute leukemia. So there is chronic, accelerated and blast phase. The treatment is imatinib. Imatinib blocks the BCR-ABL fusion protein, which has got tyrosine kinase activity. PCR located on chromosome 22, ABL located on chromosome 9, and the fusion protein has increased tyrosine kinase activity. Fusion protein 2 type, P2 type, and this can be blocked by the imatinib. That is all about CML. Thank you.